The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone and welcome to today's Dr. Ehrenstorfer webinar on food contact mindfulness. My name is James Sizer and I'm the Senior Global Brand Manager for Dr. Ehrenstorfer, and I'm lucky enough today to be joined by John Points, who is an external expert and consultant who specialises in analytical testing and will be taking us through the content of today's webinar. I'm also joined by John Wong, who is the Global Product Manager for Dr. Ehrenstorfer and is the expert on our portfolio of reference materials for food and environmental testing. Just a very quick note on Dr. Ehrenstorfer. For those of you that aren't familiar with us, we are a global leader in providing reference materials of the highest quality, largely aimed at the food and environmental testing markets. Our products are generally produced to the very highest quality, with the majority of our products produced under our ISO 17034 accreditation. We have a wide range of reference materials that are there to service almost every category of food and environmental testing, all of which can be discovered on our website at lgcstandards.com/Dr. Ehrenstorfer. A quick note on today's presentation. The presentation we're about to see from John Points actually is based on a white paper that has been previously produced and shared with most of our customers called Food Contact Mindfulness. And that white paper really is a slightly more detailed look at everything that's going on in the world of food contact materials at the moment. It's a fast rising, high profile and very interesting area of analytical testing at the moment, as many of you will know, and is one that increases in importance due to the public awareness of food contact materials and some of the alternatives that manufacturers and suppliers are seeking to bring to market. A little bit of housekeeping. If you would like to ask any questions today, you are very welcome to do so. Please do so by typing into the chat box in your GoToWebinar control panel. And then underneath that, you will see a little drop-down menu where you can select Send Question to Staff before hitting the button that says Send. If you do that, we will collect them over the course of the webinar, and at the end I will share a short session on questions where either John Points or John Wong will be able to answer your questions on our products and on the subject of food contact materials. Okay, so without any further ado, I'd like to pass over to John Points to take us through today's content on food contact mindfulness. Over to you, John.
Thank you. And as James said, my name's John Points. I'm an independent consultant based in the UK. And today I'm going to briefly describe what a food contact material is, then talk about the legal principles that apply to both the safety specifications of food contact materials themselves and to risk assessing the safety of any resulting contaminants that migrated to food. And finally, I'd like to explain, using examples, what we mean by mindfulness when it comes to the risk management of contaminants from food contact materials, and thinking beyond simple compliance. So, what is the food contact material? Well, the terminology varies around the world, but definitions are all similar. We're not just talking about food packaging. It's any material or article that comes into contact with food, or is intended to come into contact with food, or even might transfer its contents into food. This can be at any point in the food's life cycle, although notably the US treat homewares and kitchen utensils under a separate legal framework than food safety. So when you look at the variety of food contact materials throughout the entire supply chain, the scope's enormous. It's actually easier to say what is excluded. In the EU, this would just be edible packaging and drinking water pipes. Everything else is in the frame. Any could potentially contaminate the food. Now, because of this complexity of scope, from a legal view, it makes much more sense to categorize by the construction material rather than what the article is or what it's used for. Historically, the regulatory focus has been on plastics, coatings, and adhesives. These are the most obvious source of migration contamination into food, and are what would come into mind if you ask most consumers to think of food packaging. More recently, though, the risks from food contact cardboard have been gaining more regulatory attention. The EU legal framework now has 17 classes of food contact materials, although some of these are little more than a single line in the legislation. The bias of actual regulations within the framework still lies very heavily towards plastics, coatings, ceramics, metals, and glass. This will change over the next few years, though. With the scramble for food brands to be seen to be reducing and replacing plastics, the use of materials like regenerated cellulose will boom. Most food contact material legislation around the world is similar to the EU's here, in that there are two fundamental points. The first is that materials must be manufactured under the principles of good manufacturing practice. The second is that if there's anything in the material that will foreseeably contaminate the food, then you have to protect the food with a barrier film. The way that this legislation is framed dictates the way that compliance is tested and demonstrated. Regulations relate to the specification of the food contact article rather than maximum limits for contaminants in the food. So the testing is also focused on the article. This may be by direct analysis, if the entire item can be blended or extracted. But in most cases, the article specification is framed in terms of the amount of contaminant that will leach into a standardized food stimulant under standardized conditions. There are a few different standardized stimulants to represent different food types, and the conditions used are intended to represent a worst-case scenario. Specifications can either be set as specific limits for individual migrants or as an overall migration limit, which can be tested as the total substances leaching from material by weight. Leaching into standardized simulants is an ideal way to ensure comparability of test results and to support international trade in food contact articles. It's not really suitable to inform consumer exposure assessments. For this, you need to know how much of a contaminant is in the diet, how much is actually in the food that people eat. A few standard simulants can never model this. You would need to test the food itself under real-life conditions, and this is rarely done in practice. The reason that consumer exposure assessments are needed is because exposure assessment is a critical step in risk management. Without the exposure, you can't model the risk. Now, there is an important distinction here. Hazard is the intrinsic ability of a substance to cause harm, but a hazard only becomes a risk if it might cause harm at the given level of exposure. As the old saying goes, it's the dose that makes the poison. In this case, the exposure needs to be estimated from the level of a particular contaminant in the diet. Risk managers can't make informed decisions and regulations without risk assessments, and risk assessors can't make informed decisions without evidence of exposure levels. And for contaminants from food contact materials, this is a big gap. We just don't have data on dietary intake. It's likely to be brought into sharp focus in the next few years, as food packaging, in particular, undergoes rapid redevelopment and there's pressure on risk managers to react. The driver for this rapid redevelopment is consumer pressure to reduce or replace plastics. In countries like the UK, the consumer demand to make food packaging more sustainable is intense. Industry is scrambling to react. But remember, to industry, sustainability covers more aspects than just plastic reduction. It's also things like energy use, water use, and shelf life extension to reduce food waste. This leads on to novel solutions like intelligent packaging. Now, I don't think our risk assessment methodology is particularly suited to this holistic view of things. Risk assessors look at one risk at a time. They don't have the tools to balance risks and benefits, either between the different safety risks of two alternate solutions, or even between safety risks and sustainability benefits. This type of judgment has to be a political rather than a scientific decision, but it still needs to be based on evidence. I'm going to illustrate this with 3 examples. The first is the issue of mineral oils in cardboard. Now, mineral oils refers to any uncharacterized mix of hydrocarbons, ultimately derived from fossil fuels. In a food contaminant context, they're divided into 2 classes: MOSH, saturated hydrocarbons, and MOA, aromatic hydrocarbons. The ones that are a problem are the flat, planar, multiple ring MOA. These form adducts with DNA and are generally genotoxic carcinogens. The hazard, the toxic potency, is highly dependent on the individual structure, so it's difficult to assess for an uncharacterized mixture. We're exposed to mineral oils everywhere. Our planet is littered with oils from fossil fuels. Food is only one exposure source. But in terms of food exposure, contamination can originate from any point in the supply chain. Fumes from boat diesels or ovens contaminate fish or dried foods. Old wooden crates used in the country of production can contaminate things like raisins. But the issue I'm interested in today is food packaging made from recycled cardboard. This contains newspaper print, which contains mineral oils. The foods most at risk are dry, long-life ingredients and products, things like dry cake mixes, breakfast cereal, flour, and pasta. Now, here's a riddle for you. When is a food contact material not a food contact material? The answer is when it doesn't contact the food, when the migration is gaseous. And this is the case with mineral oil migration into dry, long-life foods. But when you start to think about this, it makes the definition of packaging wider and wider, and potential controls more and more complicated. Take a packet of breakfast cereal. If there's recycled newsprint in the cardboard pack, MOSH and MOA will migrate in the gas phase into the food. However, in this type of product, there's usually an inner plastic bag, but it's not a barrier film. It's designed to prevent moisture, so it might slow, but not stop, the migration. But the cereal box isn't the only cardboard packaging. These days, most packets for large supermarkets come in what they call store-ready packaging, a secondary layer of cardboard that's placed straight on the shelf so that customers reach in and pick out their own packet. So if that's recycled, then it will also have MOSH and MOA in it that can migrate into the food. And then there's the tertiary packaging, the large carton used for warehouse storage and transport, a type of carton that typically sits on a pallet. The product can be sitting on this for weeks, so again, there's the opportunity for migration. But just to complicate things a bit more, gaseous migrations and equilibrium. So depending on storage time and temperature, there'll also be mineral oils migrating back out of the food. And finally, those of you with sharp eyes will notice that this pallet, like most others, is wrapped in plastic film. This can have a huge effect on the whole system, again depending on the temperature and the length of time the carton's sitting on the pallet. Which all means that these type of migration systems are much more difficult to model, and certainly can't be modelled by tests on simulants. Any mitigation steps need quite a lot of technical thought and detail, and there's unlikely to be a one-size-fits-all solution. Now, there might be a real problem here, but without analytical evidence of what is actually in the food, we're just guessing. EFSA have given a preliminary opinion, but it's full of caveats. We know the hazard, but we don't know what our exposure is, either to mineral oils in total or to individual structures that have been identified as having the most toxic potency. And we don't know the contribution from recycled cardboard food packaging in the context of that overall exposure. A part of the problem is the method to measure contaminants in food. Although it's been collaboratively studied and issued as an EN method, many labs still report a lot of quantitative uncertainty. MOSH and MOA are separated as fractions, and each fraction measured as the sum area under a region of the chromatogram. But there's often subjectivity in where to draw the baseline. It also means that anything else eluting in the same window, like polyolefin saturated hydrocarbons that can migrate from plastic packaging, will be included in the same sum. And at the moment, there is no method or intent to measure the individual mineral oils of most toxic concern in the same way as you would do, for example, for PAHs or dioxins. Only a handful of countries have put any regulatory risk management in place or taken enforcement action. In this example, the Czech Republic have recorded an extreme case of contaminated raisins that contained hundreds of milligrams per kilogram of MOSH. Now, this is more likely to be from wooden boxes or oil-fired drying ovens than cardboard migration. But Germany and Belgium have both recalled food on the basis of their own national regulatory limits for MOSH and MOA in food. Their limits are quite complex and detailed, and Germany is now considering changing their approach and removing any limits for MOSH in food, but introducing a blanket ban on MOA in food contact articles. Most other countries, though, take the view that without reliable analytical methods or risk assessments, it's premature to set regulatory limits. All this doesn't help food brand owners who, at the end of the day, just want regulators to tell them what they should be doing for the best. If there genuinely is a food safety risk, then they need to be doing something about it. There is some very good industry guidance, but it doesn't make the tough decisions for you. There are some breakfast cereal brands who sell across Europe that have proactively changed to only using virgin cardboard packets. But that doesn't completely solve the problem without looking at the outer cardboard cartons too. Plus, virgin board is less energy efficient, and customers don't like it. They want to see recycling. The best and legally defensible mitigation is to use a barrier film. But that would be unacceptable to many customers in today's climate. They want to see plastic packaging removed. The last thing they would want to see is new layers of plastic for foods like flour or oats. As sooner rather than later, we're going to have to make a direct trade-off between food contact contaminant risks and sustainability goals. And to make that difficult judgment, we need evidence. As well as more testing of mineral oil levels in food, my view is that we need to start measuring individual compounds, using the same type of toxic equivalent factor approach as used for dioxins. The next example is per and polyfluorinated alkyl substances, which for the sake of simplicity, I'm just going to refer to as PFAS. PFAS are a number of different classes of chemical compound. All of them have a fluorinated carbon chain and a hydrophilic head. They're bulk produced as surfactants and foaming agents, but also, in a food contact context, are the building blocks of fluoropolymers that are used as non-stick coatings and grease repellents, things like Teflon. And some PFAS are incredibly environmentally persistent. The worst of them, perfluorooctane sulfonic acid, has been banned under the Stockholm Convention, and perfluorooctanoic acid is being phased out in anticipation of a ban. Now, there is a toxic hazard, although their potency is low relative to some other food contaminants. A few different toxic effects have been seen in animal studies, and it varies by compound, but generally no causal links have been proven in humans. Our main exposure to dietary PFAS is through the food chain accumulation of environmental contaminants, particularly in food like fish and dairy products. But there's also a food contact exposure source. Fluoropolymers contain residual PFAS from their manufacture, and these small molecules can leach into fatty foods, into things like frying oils, or as you might see from the state of my frying pan, whole flakes of the non-stick coating coming off into the food. Fluoropolymers are also used in grease-repellent cardboard, and so PFAS have been detected in things like takeaway food and popcorn. PFAS have been risk assessed by the European Food Safety Authority, and they concluded that there's no significant risk from current exposure levels. It's certainly better for people to maintain a varied nutritional diet than to restrict consumption of fish, which is the main dietary source of PFAS. But, and there always is a but, the assessment only covers two PFAS, PFOS and PFOA, because they're the ones that have been traditionally included in trace contaminant test suites, and so where there's exposure data available. But these are the least likely PFAS to find in food contact materials. As I said, PFOS is banned and PFOA is being phased out. There was no reason why we couldn't collect data for other PFAS levels in food. There are lots of published LCMS methods that can cover a range of PFAS, not just PFOS and PFOA. And there's only a small incremental cost to expand the analyte list. It's basically just the cost of the extra reference standards and the upfront validation time. The other caveat with EFSA's risk assessment is that because we're modelling the chronic exposure from widespread consumption of very small concentrations, most of the analytical results were non-detected. EFSA have to make assumptions about how to deal with these. They could assume anything from 0 to a residue at just below the detection limit in each case. And the risk assessment is highly sensitive to these assumptions. There wouldn't be the same problem now if the studies were to be repeated with modern LCMS test methods. These are much more sensitive and more likely to give a quantitative result for each trace level sample. So in the case of PFAS, mindfulness comes from considering exposure from food contact materials in the context of overall dietary exposure from environmental contamination. It might be the case that the relative contribution is small and doesn't warrant risk management or regulation. But we can't make that judgment without evidence. Without evidence, the danger is that industry and regulators have to take a worst case assumption and take an overly conservative approach. My final example is bisphenol A, a food contact issue that's had a high media profile for the past 20 years and shows no sign of dropping off the agenda anytime soon. Now, BPA differs from mineral oils and PFAS in that there's certainly no lack of data. BPA is probably the most widely studied food contact material there is. But it illustrates how different risk assessors can draw different conclusions from the same data, and how there could be plenty of data on one risk, but a complete absence on the alternatives. BPA's toxic hazards are related to reproductive and hormone effects, and this is because it's a molecule that mimics estrogen. In fact, it was originally developed as a hormonal medicine, although never used as such. Now, BPA has got many industrial and household uses, but in a food contact context, the most important are as a component in the construction of polycarbonate plastics, and as a feedstock material for the epoxy resins that coat the inside of cans. In terms of overall exposure, though, the most important population are probably cashiers who regularly handle thermally printed till receipts and vouchers. Although both the hazard and the exposure to BPA are reasonably well studied and characterized, there's international disagreement over whether exposure from food contact sources poses a significant risk, and some countries, notably France, have taken unilateral action based on their own national risk assessments. Now, as I said, there are two main food contact exposure sources of BPA, although its use in polycarbonate kitchenware is so rare now, but its contribution to exposure is minimal. It was a different story in the 1970s and 80s. Polycarbonates were lauded as dishwasher safe, microwave safe, freezer safe. But it would be a brave manufacturer now who labelled their food containers with added BPA so you can dishwash with confidence. It's not actually banned in most countries, other than in products for infants, but consumers just won't accept it. BPA-free labels are almost a prerequisite for sale to some consumer groups. So the main remaining exposure source is canned food. And there's a very good reason for the existence of epoxy coatings. They've virtually eliminated the botulinum risk that canned food used to pose. But BPA-based resins are in the process of being replaced by alternatives by most multinational food suppliers because of the French unilateral ban. It's uneconomic for them to manufacture two types of cans, one for the French market and one for everywhere else. And the reason that consumers won't accept BPA is the terrible media image that it's had over the past 20 years. This hasn't been helped by the bans of BPA in infant products. These were supposed to be precautionary rather than risk-based, but they just cemented the idea in consumers' heads that BPA was poisoning us. And it hasn't been helped by the inconsistent conclusions from different risk assessors. The quite reasonable argument goes, if the French have banned it, then why haven't our government? So, regardless of the scientific debate, BPA's days as a food contact material are numbered. Manufacturers are introducing replacements for the remaining uses as rapidly as possible. So what can they use as a replacement? Well, the easiest technical solution is a straight swap for a molecule with similar stoichiometry and functionality. And there are a whole host of similar bisphenols that have been used as direct substitutes for BPA, either as the building blocks for epoxy resins or to form analogous polycarbonate plastics. Many are based on the same bisphenol core as BPA, with various substituents, either on the phenol rings or on the central carbon. Some are based on a sulfur rather than a carbon molecule in the center of the structure. The most well-known of these is BPS, and it's estimated that probably around 60% of the BPA that's been substituted directly for another bisphenol compound has been switched to BPS. That still leaves a long list of other replacements, though. So what's the safety risk from these replacements? Well, the short answer is nobody really knows. Through lack of mindfulness, we found ourselves in a situation where we're moving from one substance, which, although there's disagreement on the interpretation, is probably the best studied food contact material in history, to some that have been barely studied at all. And this isn't an academic question. It does seem a reasonable hypothesis that, given that the bisphenol structure of BPA was developed to mimic estrogen, then other bisphenols might have similar toxic effects. Now, most laboratories that test for leaching into simulants, or even that survey contaminants in food, still only include BPA and BPS in their test methods, and BPS is a relatively recent addition. There are very few data on other BPA analogues, either on their toxicology or on their occurrence as food contaminants. And there's no real excuse for this lack of data, certainly not for data on exposure. Laboratories could test for more analogues if their customers requested it. The methods they currently use for BPA and BPS would equally apply to other analogues. And in fact, instrument vendors and research groups have published application notes and methods to prove this. A wide range of high-quality reference materials are available from companies like Dr. Ehrenstorfer. And, like PFAS, the incremental cost of widening a method's scope is relatively small. So, I'll leave you with this challenge. If you're commissioning a laboratory to look for food contact contaminants, or even if you're a laboratory developing new services, why not widen your specification scope and contribute some real data to the global knowledge pool? So, what conclusions can we draw from these 3 examples? Well, my view is that without evidence of contaminant levels in real food, rather than simulant tests that are designed to measure compliance of a food contact article, the need for risk assessments is going to outpace the available exposure evidence. And without that evidence, risk assessments are little more than informed guesses. This is likely to be brought to a head in the next few years with rapid developments in food packaging as we move to replace plastics. But once we have this evidence, we need to take a holistic view. Rather than just looking at one risk, what are the relative risks of all the alternative solutions? What are the risks of substitution or removal of a material? Including both safety risks, but also other factors such as environmental risks or sustainability goals. Food contact materials is an area where we need to balance risks and benefits, rather than assessing and regulating each risk in isolation. This mindfulness applies equally well to reappraisal of well-established materials as to the introduction of new materials. But it's the new materials that will drive the agenda, and are posing these difficult questions that can only be addressed with the collation of good analytical data. So with that, I'll hand you back to James, and I'm happy to take any questions you may have.
Thank you, John. I hope you will all agree that was a very interesting presentation on food contact mindfulness and, of course, the category food contact materials. I think from everything that John has just walked us through, it's really clear that the world of food contact materials, in its sheer size and scope and the number of areas in which it reaches, both in the average consumer's lives, but also in the world of food safety throughout the processing chain, means that we can only expect analytical testing demands and regulations to increase in this area. I think for companies such as ourselves and for brands such as Dr. Ehrenstorfer, our whole mission is really about supporting you in your own science for a safer world. And to that extent, it's our commitment to produce reference materials for food contact materials that really meet the demands of that analytical industry by being of the highest quality. So as mentioned at the top end of this webinar, we do produce a series of reference materials for food contact materials in their many guises under our ISO 17034 accreditation. So if you have any needs in this area, then please do let us know. But the other thing that I would mention is that we're not just here for products, we're here to support you. And so with that in mind, please do download our food contact mindfulness white paper. So this is a white paper produced by John and actually goes into a further detail about the category and some other examples where we explore those looked at today further. But we also add in the world of phthalates and photoinitiators. So it's a really comprehensive look at food contact materials along with some detailed examples. So I do urge you to download that. I've actually just posted a link in the chat box for that white paper, should you not already have it. In addition, we have also prepared a food contact materials brochure. This brochure breaks down the whole of food contact materials as a category into some significant subcategories, including those examples you've seen today. And we have also made that available to download and browse. That is on our website on lgcstandards.com and can be found in the resource and publications section. But I will also post in our chat box a quick link to that as well. So please do have a look at that if this is a particular area of interest to you. So that all said, those are our key areas to read on and find out more. But now is also a great time to ask us any sort of questions. So I have a questions box open. I don't have anything in front of me at the moment. So now is your opportunity. If you have any questions for John Points, or indeed John Wong, who is our resident product expert on reference materials for food and environmental testing, then please do post in the chat box, then select send question to staff from the box below and hit send. And I'll keep an eye out for any questions incoming. Should you not feel like asking a question today, but find that you have further questions as you navigate the world of food contact materials, I would also just quickly mention that you can always reach out to us through the various means. So by all means, please do come onto our website, which is lgcstandards.com/Dr. Ehrenstorfer. And there you'll find a contact us section, which will give you a link to our local offices. We're part of the LGC family, so we are present around the world. But also you can submit questions online, explore our whole section dedicated to Dr. Ehrenstorfer white papers, and you can also explore our extensive product category, which covers not just food and environmental reference materials, but those in other industries and sectors as well as a really comprehensive proficiency testing scheme, which again has a number of samples that are directly relevant to the category of food contact materials. And in fact, I know that we have recently launched a PT sample for BPA, so that may well be of interest to expand upon your testing remit. Okay, so at the moment we don't have any questions coming in, so that hopefully means that you've learned an awful lot today and that we've been as comprehensive as possible. So with that in mind, what I would urge you also to do is engage with us on our social media communities. So we are present on LinkedIn and Twitter, and our tags and our names are on screen now, but it's essentially Dr. Ehrenstorfer on both LinkedIn and Twitter. And this is where we share our latest product information, but also things like our white papers, any thought leadership. We also post about the latest developments in regulations and news, and also how we can widely support you in your analytical testing. So please do join us in those communities and contact us that way. Anything you want to know from us, if there's anything we can do to help, we would be happy to do so. Okay, so with that, I would like to draw this to a close, and I would just like to say thank you very much for joining us today. We do hope that you found it informative and useful. And then finally, also, I'd like to say a huge thank you to John Points, who has put together this webinar for us and delivered this great presentation. And also to John Wong, who, although hasn't spoken today, he has been on hand to support us and has played a key role in putting together some of these examples with John. So thank you very much for joining us today. And from all of us here at LGC and at Dr. Ehrenstorfer, I'd like to say thank you and goodbye.